All right, well, it's just about 1:04, so we will go ahead and get started. Good afternoon, everybody. My name is Sarah Patterson, and I'm the Executive Director of the Property Management Association. And I'm excited that we have more than 50 people here today, and we thank you for joining us for this webinar. Since 1952, PMA has enabled property management professionals to advance professionally by offering practical education and networking opportunities that help property managers become more successful. Of course, we've had to do the 2020 buzzword of the year, pivot, and offer those opportunities in a different way. So we thank you for joining us. Our membership includes hundreds of companies who provide products and services to the property management industry. And we always encourage our property manager members to visit our online directory when seeking services, as our members have truly demonstrated a commitment to our industry. And there's one group of associate members to whom we owe much of what we do. If it weren't for the generosity of our corporate partners, we really wouldn't be the vibrant and robust association that we are today. So let's take a moment to recognize our corporate partners, starting with our platinum partners, which include Inner Solutions and Tepfer Construction Company, and then our 5-star sponsors, which include American Pest, Capital Canopies, ESSI, Finley Asphalt and Concrete, Hawkins Electric Services, Minkoff Company, Multi-Housing Depot, Owl Pest Prevention, Residency Bureau, and TRC. In addition to logging onto our website to check out our online directory and all that good stuff, I encourage you all to keep an eye open for communications from PMA regarding upcoming events and activities. You'll soon be receiving information regarding a bylaw amendment, as well as a call for candidates for PMA's board of directors and other leadership roles. We'll also be soliciting nominations for our EPIC Awards, and our committees are hard at work developing a mix of fun and educational programming to keep you informed and connected. And when I say fun, we're talking about s'more meetings, wine meetings, mixed drink meetings. We're really trying to think outside of the box and do some fun things to encourage you guys to stay connected at this time. So PMA's Operations Council is pleased to present today's webinar, Preventative Maintenance and HVAC Strategies for Resident Health and Well-Being. So let me tell you a little bit about our panelists. First, we have Sasha Serpa, who's the Vice President of Sales at Quality Air Services. Sasha has worked alongside many building managers and engineers over the years in helping to solve their building's unique HVAC issues. Quality Air Services has been around since 1998 and focuses on serving the heating and cooling needs of older multifamily properties. QAS stocks hundreds, if not over 1,000 different fan coil units of varying sizes, types, and configurations, which many apartment and condo buildings rely on for in-unit cooling and heating. Quality Air Services focuses in this niche of hydronic systems, has made them the expert solution for many multifamily properties in the DC metro area. QAS offers the more typical HVAC equipment service and replacement, along with a variety of unique services designed to make the lives of their clients as stress-free as possible. Also joining us is Elizabeth Kirk. Elizabeth is the Marketing Director at TRC Engineering, and she'll be helping us monitor the chat today. Speaking of which, throughout the conversation today, if you have questions or comments, please share them in the chat, and we will share them with the presenters so that they can be addressed. So like I said, Elizabeth is with TRC Engineering, and for those of you who don't know, TRC is an area leader with a team of experienced engineering professionals specializing in mechanical, electrical, and plumbing system analysis, troubleshooting, maintenance planning, design and retrofitting, as well as other engineering services. And last, but certainly not least, is Ted Ross of TRC Engineering. Ted has been a fixture in the property management industry and PMA for more than 2 decades. In fact, he was one of the driving forces behind the creation of PMA's Operations Council and Maintenance Summit. He has taught numerous education programs for PMA, and he's an instructor for the National Association of Power Engineers Educational Foundation and the Building Owners and Managers Institute. Ted has earned several PMA awards. In fact, he's the first ever recipient of PMA's Capital Achievement Award. He's co-chaired committees and was on the Associates Membership Council and Board of Directors. And there's so much more I could say about Ted, but I will turn it over to him now to take it from here.
Well, thank you very much, Sarah. And folks, today we're going to be talking about preventive maintenance systems and preventive maintenance for it's HVAC systems, but we are going to focus today on ventilation systems because that is what's affecting people's health the most during this COVID crisis. And we're going to talk about moisture in the buildings, how HVAC can affect the human comfort, air balance, circulation and ventilation, and exhaust systems. So one of the things to consider in all buildings is the moisture intrusion. And where does that come from? Most buildings should be neutral or slightly positive. But as buildings age, many of the building shells develop leaks. Some of them the leaks can be exacerbated if the building is negative, but the water can infiltrate through the sides of the building. It can also come in with outdoor ventilation and air, and the respiration of occupants can produce moisture along with the permeation through the walls. And last but not least, piping leaks. As these buildings get old, the piping can leak. And if moisture and air, especially this week of all times, penetrates the building, and as it goes into the building, it can condense on cooler pipes, and you can have condensation leaks, and even the walls of the office and living spaces. So to help prevent that, it's important to have your building balance correctly. And we're going to talk about that in a few minutes. But the roles of HVAC is heating, ventilation, and air conditioning. Today, we're focusing on the V in HVAC. And we need to provide fresh air. The ventilation has to provide fresh air, thermal comfort, the dilution in the ventilation system. So the old air and the new air has to be mixed up, and as air is discharged, but we want to mix that air up. Local exhaust systems for many buildings helps get the air out of the building that is contaminated with CO2, CO, but these conditions, and sometimes you can see that buildings do something called pooling or puffing of air. One of the things I like to look for in a building is if I come in and I have to pull the front door of the building open, and if it's not a vestibule, but it just opens in the building, that might be an indication that there could be a problem. But the conditions can occur often in buildings where they're puffing, or if you have to pull doors and windows open. If it's overpressurized, the doors may not shut and the windows may not shut. So the building pressurization helps prevent moisture from transporting to the areas you don't want it, and biocontaminants as well. So thermal comfort is very important in buildings, and some of the major factors of thermal comfort, besides the temperature, or what we call in the industry dry bulb temperature, you can see here 71.5 is typically a fairly good round number. But humidity is important, a 40 to 60% humidity in the building. And you must have air movement, as we said before, because air can stagnate. And one of the most common standards for ventilation used is about 5 CFM of fresh air, cubic feet per minute ventilation from the outside, and less than 1,000 ppm of CO2. And CO2, when we inhale, we're inhaling oxygen. We're inhaling air that has about 21% oxygen in it. And when we exhale CO2, and that can pool because CO2 is heavier than air. So usually pools and lower spaces. And we want to have air provided to the building, fresh air, because it typically doesn't have, we don't want it to have irritating contaminants in it. If there's a construction site nearby, that could provide some contaminants that are not desirable. And then we also want the ventilation systems to have a low noise level. If you're in a room, and particularly a conference room is most noticeable, and you hear the air handler running or you hear whistling or ventilation, it can be distracting. And that is not correct. You typically don't want to hear noise rushing when you're in the building. And another important factor that affects human comfort is adequate lighting in a space, and then proper furniture and workspaces. So the building air balance is important. Most notably, buildings, pretty typically, they're air balanced when they're new or during major renovations. But to ask yourself the question, when is the last time your building was air balanced? Building owners can contract for formal air balancing, and somebody who does air balance should be a member of TAB, Testing and Adjustment and Balancing Bureau. They recommend system balancing during major construction and remodeling projects, such as the addition of windows or major construction to the outside of the building, or major HVAC renovations. It would be important to have an air balance, particularly with the ventilation systems, not so much the heating and cooling units, but more the ventilation systems. Even in the case of new systems, the association's SIMCA, the Sheet Metal and Air Conditioning Contractors National Association, which many of the air balancing companies are members of, they provide guidelines, and all of you can look these things up. And it might include careful visual inspection, photo documentations, as well as discussing the issues that they found during the testing of the air in the building. And many contractors can give you an idea of how that's going to go. In most buildings, we want it to be slightly positive or neutral. And you can see from this diagram with the air pushing out, it can push out outside the building. And this warm, moist air that we have this week, we don't want that inside the building unless it goes through the air handling system. And this first diagram on the left, you can see it pushes the air out a little bit. If the pressure is too high, they can create other problems. And besides the doors and windows not closing very well, if they do open or close, you're basically heating and cooling the outside of the building and the air around it. You don't want that. If it's too negative, then that negative pressure, there's all types of cracks in buildings, can pull this warm, moist air in. And as soon as it hits a wall from an air-conditioned space or the cooling pipes or other areas that are cooler, it will condense, form moisture, and you can get mold growth. And none of us want to see mold in the building. This is an example of a real-life building that had massive ventilation problems, and it was actually during new construction, and things weren't done correctly, and you can see how high some of the readings were in comparison to the base. And as it went on, and you can see where it was improved on the previous slide and this slide. This is where the improvements were made dramatic changes. But they had mold up in the interstitial space and the ceilings developing because they had warm, moist air coming through the exterior of the building, going above the spaces and it would condense on the ceilings or the walls, and the mold, they had moisture, and the mold actually penetrated the drywall. It was so bad that I could feel air coming through the electrical fixtures. I've seen that a number of times when it's in extreme cases. So the balancing needs to be measured and done correctly so that all the fresh air coming in the building, once again, is going through the HVAC system as it's designed. And I mentioned before about how important it is for the ventilation system to dilute the air, because contaminants can come from inside a building. We have outside air come in, but we can have return air from spaces. But sometimes during construction or modifications within a building, items can, carpet, furniture, other building products, and when people move in or out, if they have new furniture, that can off-gas contaminants into the breathing airspace. So we want to have everything circulated and mixed up, and the temperature and the humidity maintained well. Air handlers provide this mixing of the old air that's in the building and often exhausting the air. Rooftop air handlers in particular, so if your building has a rooftop air handler for the hallways and the lobby spaces, it may very well exhaust as well as add new air. Many buildings have their own separate exhaust systems, but some of the air handlers will do that. And it provides conditioned air at the right temperature, humidity level for the occupants in the building, whether it's heating or cooling. And it also filters the air, contaminants from outside. So it controls temperature, controls humidity, ventilates, filters and ventilates the air, and distributes the air to the building. And all of these are controlled by the air handler itself. This is a typical drawing of an air handler. And pay attention to some of the parts, because we're going to be talking about the preventive maintenance later in the presentation, but this particular air handler, this is one of the typical rooftop air handlers. It has dampers to adjust how much it exhausts. It has dampers to adjust the outside air coming in the building, and dampers, and you can see this on the left side of your screen, to adjust the recirculating air that's coming from the spaces, and it can be mixed in with the fresh air coming in the building, and then it's either heated or cooled. And then we have a supply air fan and a return air fan. Very typical diagram of an air handler. And we notice at the bottom we have a three-way valve for both the heating and the cooling, and that's where it can mix and maintain the temperature accordingly. This next slide is an air handler, and this is a recirculating air handler, and it's important to understand the differences, because you'll notice there's no outside air coming in. This is one that you might have for a community room or a large meeting space, and it takes air from in the space across centers, brings it through, heats it and cools it appropriately, and goes through the supply fan and is distributed to the space, and the temperature is maintained by a thermostat. And the temperature is controlled. The next one here, you can see what's been added is after the heating coil in the bottom of your screen, there's a steam humidifier. So now they can control the humidity, not just the temperature, but also add humidity to the air with steam. Remember, 40 to 60 is what we like to have for human comfort. And in this air handler, we've now, besides humidity, we've added a filter, and we have added an outside air damper. So now we can bring outside air in, and you can see that on the bottom of the screen. So you can see the complexity, the more equipment that's being added. Every one of these items need to be on a preventive maintenance system, that someone tracks, and things need to be tested, examined, and cycled to ensure that they work. Now, this air handler now, it's becoming a little bit more complicated. It has a relief fan, and that relief fan goes right into what we were talking about earlier about maintaining building pressure. And that has a sensor to maintain the pressure correctly. We also, in this particular case, we've added an exhaust fan that's separate. And it could, and many of the large buildings, such as the building behind Sasha, they would have many rooftop exhaust fans that exhaust the air from the building, as well as adding fresh air. So low or no ventilation in buildings can create many problems. Often TSP, or totally suspended particulate matter, includes solids and liquids. So you might have construction site outside, and one of the worst is maybe some cement dust or some type of dust from the construction site that's brought into the buildings. And then we could have gases, and they can be organic or inorganic. I talked about the off-gassing of new furniture, new carpet, and such things. And there could be sources that could have combustible gases in them. And we see often when the building ventilation is off, garage, the exhaust in the building, and if the garage fans aren't working and the building ventilation is off, it can suck carbon monoxide from the garage into the building, and that also can create a problem. But you could also have problems with bioaerosols, as well as many other issues. Today, we're thinking about COVID-19 and such things that can be transmitted with multiple people in a building. And these systems have to operate effectively and clearly to help reduce the chance of cross-contamination of COVID. All the ventilation standards in buildings in our industry and the HVAC industry is governed by an organization called ASHRAE, and you can look that up. But in particular, the ventilation standards are ASHRAE Standard 62/1989. Those standards, and there will be new ones that will come out, but ASHRAE publishes the standards periodically. Now, heating and cooling components in a building, we're mainly talking about the ventilation system, but we talked about some of the moisture generators, but we also have heat generators. And you can notice in this picture, lighting can be a big heat generator, particularly if lighting retrofits haven't been done. Some of the old incandescent and old fluorescent lights produce a lot more heat. People produce heat. The solar effect and the sun effect on a building can have a very, very large effect of the heat on the building. And today, you see the computer sitting on that guy's desk. There are so many electronics in buildings today. That's something often that was never considered in the past when many of these buildings were built, was the amount of electronics that we have running in buildings that produce heat. So the cooling load components that we consider are infiltration, glass, the condition of the glass. Do you have low E glass? How well is the insulation in the building, and how is that going to help insulate the building against solar heat and other things? So when engineers look at the heat load of building, and you have an engineer come out to design your new air handlers, your chillers, your boilers, or any parts of your HVAC system, whether you have heat pumps or whatever you have, the amount of heating and cooling that's done is very important because it has to do with the heat load of the building. And the engineers look at many of the components in the building to come up with the correct number. Common problems that can be caused by unbalanced buildings. We've spoken about some of them, and you see little water droplets coming from the AC system, that's representing a rooftop system. So there'd be condensation dropping from a system that isn't adjusted correctly, or the ducts that may be running outside the building or other places that have cool air, but maybe they're not insulated. And there could be condensation developing in ducts as well. You can have drafts from the front doors. If you have a negative building where you can see a little plus sign, the pressure is higher outside the building than inside the building, that can come around window cracks, through masonry, boards, all types of things. We've seen so many issues with leaks in the buildings when it's negative, how that air can come in the building and cause problems. So it can be very extensive. Some spaces may be set up, and buildings may be set up for what's called a perimeter and interior space. That's a little bit more, we see more of that in commercial buildings, but I've seen many apartment buildings and other multi-unit residential, I've seen that might be common use buildings where you might have office suites, retail suites, and other types designed. So you may run into this. But those are set up in particular where each floor controls the ventilation, but it flows maybe on the interior to the exterior, and around the perimeter, we might have additional heating and cooling units, because that affect and particularly in buildings with a lot of glass, that solar effect can be so high. But it can be changed how those buildings' temperature is controlled. And if it's an office space, for example, the building automation system may implement some night setbacks or change how the temperatures are controlled from the interior to the exterior. ASHRAE also has put out a position paper on infectious aerosols, and you'll notice all this can be sent to you if you wish it. But you'll notice a date on this one, April 14th, that's since COVID. So this talks about UV lighting and adding UV lighting, and how do we prevent, how do we help prevent the cross-contamination that may happen with viruses and other things. It talks specifically about how important the building air balance is, that the ventilation system is working correctly. Believe it or not, we have seen at the beginning of COVID in particular, people were worried about contamination, and we saw people turn air handlers off. And they figured if the air handlers weren't working, they weren't circulating things, people would be safer. And that exasperates the problem and makes it much worse. So this document is worthwhile reading if you haven't read it, or your building operations personnel haven't read it. But it does talk about installing UV lighting. There are many tests underway right now to try to figure out what UV lighting does to COVID-19. We know it kills other viruses, SARS, COVID-2, but there's no, the tests are underway now. There's no proof that it kills COVID-19, but it's reasonable to assume it does. The Navy used it in hydronic systems, has been using it for many decades. It's been used extensively. It's not new technology, but now it's becoming a little more popular. Recently, the CDC recommended UV lighting to be utilized in buildings. And a great place to put it is in the ventilation systems. Now, it's important to remember, and you have to read the instructions, have somebody design, make sure this, if you're going to install UV lighting, it's designed by somebody that can design it. Because UV lighting, you're not just going to go put UV lightings up in spaces without shielding them. UV lighting can be dangerous to the eyes, and you can't look into UV lighting without creating damage. So it has to be installed accordingly, but it does work. It kills many viruses and unwanted bacteria. Okay, Sasha, would you like to take it from here?
Sure.
And if you have anything to say about the COVID and
Yeah, just a footnote on the UVC lighting. We have been getting a ton of calls on UVC lighting, and you stressed the most important thing, Ted. First off, it is not for every application as much as everybody wants it. It is not meant for every application. There are a lot more no, this will not apply to you than there are yes, this is a good fit for you. So it is important to take that in consideration. As well as partnering, like Ted said, with the right partners to make sure that you're getting a product that's not a check the box product, but something that's actually solving your problem. There's a lot more we can talk about that. We've done extensive hour and a half long presentations just on UV alone. So if you're interested in that, we can certainly set something up through Sarah and Ted and so forth. But going into PMs, preventative maintenance programs. In our field, what we see a lot, PM systems, both computerized systems and manual systems, are really not getting the love and care that they very much should on an annual basis, biannual basis, quarterly basis. Each building should have a planned maintenance program, which they have a log of everything that needs to be checked on a daily, weekly, monthly, quarterly, semi-annually, and annual basis. And this is everything from the individual isolation valves for their hydronic systems for their pipings, which need to get worked so they don't end up becoming stuck after many years of non-use, all the way to something as simple as filter changes and so forth. As far as the components of the air handling system that you guys are most familiar with when getting a PM done, obviously you're replacing filters, you're cleaning and ensuring that you're getting hands-on all the bolts and all the fittings, just so that make sure that anything that has come loose is getting eyes on and getting tightened. Visual and physical inspections, obviously, you're checking your motors, you're checking the amperage levels to make sure that everything is copacetic. You're replacing your filters, and you're making a note at that point in time. When was the last time you replaced the filter? What is the condition of the filter at this point in time? And do I maybe need to increase my frequency of filter changes? And just to touch on that, a lot of folks are also asking about increasing the MERV rating of their filters, from whether it's just a poly throwaway filter they currently have to a MERV rated, MERV 8, MERV 13, or whatever have you filter. That once again, that's not applicable for all situations, but if it is, just be aware that the higher the MERV rating, the more dense the filter, the more particulates it catches, the more frequently you have to replace it. So if you are going that route, filter changes should increase. Obviously, your ventilation, supply return, air discharges, duct cleaning, that's important and usually forgotten. But it is not something that needs to be done certainly on a semi-annual basis or anything like that. If you keep up with your filter maintenance and your PM schedule, that's something that can be done as needed. Operation of all switches and valves, like we mentioned earlier, to ensure proper functionality. The valves should be worked, and then obviously keeping notes of everything. Right, you got to record everything. You got to be consistent with it, and you've got to do it on the regular schedule. Next slide. Yeah, this is Ted's got a few photos in this presentation, and I'm assuming, Ted, this is a photo that you want to point out the condition of the valve that is located at the bottom right.
yes, you can see the valve is in poor shape, but above it you can see that there's mold up against the ceiling and the wall here. So this is where moisture has condensed and caused mold. But the condition of the valves, and when you get that blue mung on the outside of pipes and things, typically that's a sign where you might have a leak.
Yeah. This is, I'm sure everyone recognizes, this is a photo of a dryer exhaust vent on the exterior of a building. These do need to be taken off. They're meant to be removed. They're meant to be cleaned. And depending on the setup of the dryer that is inside of the apartment or the laundry room, you may not have the ability or access to do it all from the outside or all from the inside, but that's certainly something that needs to be done on a regular basis. Stuff is very flammable. That one is missing a screen, so it's probably a nice nest for some birds.
Yes.
And this is an example of this is a laundry room. where you've got a drier exhaust that is hooked up to a duct, but you also have a building exhaust, a room exhaust that are hooked to the same duct. So you've got room exhaust and you've got dryer exhaust all trying to leave through the same duct cavity. And in the next picture, I believe, will be a photo of what got pulled out of there. It's beautiful.
And it's typically not a good idea to have your hallway exhaust and your dryer exhaust or another room exhaust together in the same duct. We have seen that occasionally. It may not have been part of the original design. It could be added later. Besides being a fire hazard in these COVID times, these dirty exhausts can collect things, and you want to keep your ducts clean from a safety standpoint. Did a seminar. These are extreme fire hazards when you see dust like this. I'm a former scoutmaster, and we used to tell our boys to go to mom's dryer and pull out the dryer lint for a fire starter. It does amazing things. One little match to this, and it just burns rampant in a duct.
So here's an example of filters that obviously needed some desperate TLC, and you can also see that the filter has been left in there so long. It's got moisture damage on it. It's collapsed entirely on itself towards the blower. So these things are well beyond their serviceable lifespan. This is all too common of an occurrence when visiting job sites. So exhaust system controls. What I can speak to on this is there's a lot of clients that we've been to who have asked us just on a very simple menial task of, would you please replace the burnt out roof exhaust fan, which is servicing our bathrooms or our kitchens or common hallways. And while certainly it's no problem and it's quite easy and simple to replace these things, the hardest task is oftentimes figuring out what an appropriate replacement fan is. Most buildings don't have their original design parameters for the roof exhaust fans. We don't know what the original CFM, the cubic feet per minute rating, at what the design static pressure of that specific duct load was. So we've gone up there, and buildings have extreme negative static pressure. All of their roof fans have been overbuilt and installed because nobody's had that information, and their doorways are being slammed. The building is pulling in so much unconditioned air from the outside, and unfortunately, the prognosis is all of the fans have to be replaced again. So you really want to be sure to do your due diligence in figuring out what the correct fan for that application is, and that's going back to the original design. And if you don't have the original design, then you hire somebody like TRC to figure out what the new fan would need to be on that roof.
And it's common for people to say, well, this was a 15 horsepower fan, so we'll just replace the motor with a 20 just to be safe and sure. And what they've done is they've often increased the fan capacity, and that's contributing to a negative situation.
Yep. This is an example of a roof that is, this is natural ventilation, naturally induced ventilation. There is no fan. It's really just ducts that are ventilating through natural draft. Hot air rises, it escapes the building. Not the greatest system, but considering this building, I don't know, Ted, what was it, the 30s or 40s this was built?
I think this one may have been older. Yes, it's one of the very old buildings.
This is a typical call for, my roof or my kitchen or bathroom exhaust is not drawing any air out. So really, the first place to start is obviously with a roof fan. And Ted, I think you came across this one. If you want to talk about what you found when you got this call.
Yes, remember those pictures with the lint in the dryer exhaust?
Yeah.
The fan that was ventilating the hallways in the entire building, plus somebody piped all the dryer vents into the same exhaust. And we got the call, it wasn't working. It was in this time of the year in the summer. It was hot in the hallways. We went out, and it doesn't show it in this picture, but the pulley has come off this motor. You can see the motor is fairly new. It's laying in the bottom of the shaft because there's a little key with a set screw that holds it in place so that when the motor shaft turns, the pulley turns the belt. Of course, that wasn't happening. But it's not uncommon to find these kind of issues.
But this is a perfect example of preventative maintenance not being done, right? I mean, if there was a PM program that this should have been identified. You know, on the roof side, you've got belts, you've got bearings you have to lubricate, you got belts you've got to replace. Obviously, you're making sure that everything's tight, but this should be happening. Belts should be getting replaced at very least once a year. A lot of manufacturers for their fans will suggest twice a year. Bearings ought to be getting greased at least twice a year, sometimes quarterly, and don't forget to take the plug off of the other side before you do so. So there are certainly PMs for every piece of equipment you have. Every single piece has a PM schedule, should be kept to. Cool. Sign us off, buddy.
Thank you very much. I hope this is helpful to you. Now we're opening the floor for questions.
And I have a bunch of questions here.
Oh, great.
Thank you, Sasha and Ted. First question, would you recommend tab during a controls retrofit?
Depending on how long it's been since the last air balancing. So if you've had trouble with the controls and the building looks like it's, the controls have been out and you've had a lot of trouble with them, you might consider it. A building air balancing is not cheap, particularly if you can't remember the last time the building was air balance checked. Then it's any time is a good time to do that. And a controls retrofit would be appropriate if you can't remember the last time it was done.
If I could just add something on balancing the building air. So you may want to do it, but you may find that in order to do it, there's quite a bit of work that has to get done ahead of any actual balancing work. Keep in mind the balancing of the air, the manual process that goes into that is going into, aside from the actual piece of equipment that we're referring to, whether it's an exhaust fan or an air handler, it is going into every supply and exhaust register and manually dampening the registers. They have dampers behind the actual register itself, and adjusting it and testing it to make sure the correct amount of airflow is coming out over into that space. So if you do not have an air register that has a damper installed into it, then that is something that has to get replaced. So as just to Ted's point, it is not something that is a quick and easy problem to solve, and sometimes it is fairly costly if there are retrogrades and upgrades that you have to do.
Is there a quick way to check a building?
Yeah, it's fairly easy to see if you have the right grills, assuming that you haven't or nobody's gone through and upgraded their own condo or apartment units, in this case apartment units. Maybe just a simple check of a kitchen or a bathroom exhaust register themselves. If you shine a flashlight into that register without even cutting off the paint and peeling it off, you should be able to see if there's a set screw in there and a damper behind there that you can adjust. And if you do have that, then you should be okay in terms of being able to get a balancing company in there. If you don't have that, then we're talking about replacing all of those.
And how about briefly checking the building pressure to see if you are?
Yeah, I think that's something as simple as taking an account of what equipment you currently have exhausting versus what equipment you have supplying air. And that's something that I think you guys are more than familiar with doing, aren't you?
Yes.
So I have a question. When you open the door to a building and you have to pull on it really hard, your building needs to be balanced, doesn't it?
Yeah, I think Ted alluded to that earlier in a presentation, 100%. How many doors slam behind you as you open them? Or do you have to struggle opening?
The exterior doors.
Yeah.
I have a lot more questions, guys. Okay.
And I was in one the other day that they had the plastic flaps hanging down the loading dock, and they were blowing into the building. They were probably at a 45-degree angle. So when you have that kind of issues, you might have a problem. Go ahead.
All right. What are the parameters needed to incorporate UV lighting?
So the parameters needed are actually quite, there's multitudes of them. And I would tell you that the best thing to do first and foremost is contact somebody that understands how to spec UV lighting. And you've got two of those such companies here today. But some of the things to keep in mind, number one, are UV lighting is best served in applications where it is out of sight, out of direct line of sight for anybody that is walking through the space. The best applications are going to be your common area air handlers, which are typically inside of dedicated rooms where realistically only maintenance personnel have access to. There are controls features with the lighting so that if an access panel gets opened up to that air handler, the light automatically shuts off. And there are viewports you can install to quickly see if the light is working after everything is closed off to ensure that it's operating as intended. That is
Is there a sign or notification put somewhere?
Yeah, absolutely. There's quite a few of those that get posted up, dummy-proof signs that warning, 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 all over the place. But obviously for anybody who's having this installed, you're going to have to get the training of your personnel to sit down and make sure they understand what this is, what the pros, what the cons are, what the PM schedule for it, because it does have a preventative maintenance schedule. Just because the light shines doesn't mean it's working. You do have to replace the bulbs every year. They will continue shining purple, but you still have to continue replacing them each year for the strength of the bulb to be where it needs to be to kill things.
And particularly in an air handler that is recirculating air. If the air handler, all it does is take outside air into the building and blow it into the hallways, which is a typical place, you probably aren't that concerned about the COVID outside. But if it's pulling return air in, or if it's a party room air handler, or something that is mixing the air that's in the building, it might be a good.
Yeah, party room, fitness centers, another great candidate. One thing to know, just a byproduct of UVC lighting, it is incredible what UVC light does in terms of cleaning a coil. So these things are mounted on the discharge side of a coil, and the light has to penetrate all the way through the coil. Hence, you need multiple light tubes to cover the whole area and face of that coil. But the results that you will see, aside from the protection you get from certain bacteria and viruses and so forth, is how clean the coil itself is. So you're not having to do coil cleanings on that unit past the point of installing these, because it does essentially kill everything organic. And a lot of the things that cling to the coil are clinging because of organic matter on the coil.
All right, we have 6 more questions. Can you please discuss the role of smart building technologies and building automation systems in monitoring the performance of HVAC equipment to ensure it's operating as intended?
Oh, yes, that's very good. So a lot of the smart building systems and the computerized operation of the buildings, they have histories, and where there's a reading of some type or a sensor, typically that can be recorded so you can have graphs and you can analyze how the air handler is working, how the whole building system is learning. And most of them have features where you can bring in data and information from other parts of the building to see how it is functioning. Many air handlers and other parts of the building may already have building pressure sensors on it. And then you can tell what the actual building or duct pressure is in relation to the surrounding areas. And how well the system is utilizing its utilities. Remember, preventive maintenance, some of you may have been at seminars I've done in the past where Pepco, BG&E, many of the power companies offer incentives for you to develop a good, aggressive preventive maintenance program, because it's step number 1 in energy conservation. So analyzing your utilities in comparison to your building operations. Hopefully that answers the question, Elizabeth. 5 more to go, right?
No, people keep asking. Okay, I'm going to go to the ones in chat for a moment to break it up.
Okay.
Someone is wondering if you have heard any concerns with exhaust fan systems being a source of shared air between units, in apartments?
I have seen typically if the exhaust fan is working well and the duct is clean, then it shouldn't be a problem because it will pull the air out of all the connected duct. But if it hasn't been clean and you have vast restrictions in it, it's possible that you're not getting enough air out of the space. But I'm not aware of how an exhaust fan, if it's working in its present configuration, where it could take air from one space and put it into another space.
Correct.
Okay. I have multiple buildings that the units only have exhaust fans and the only conditioned air is supplied from the hallway. It's blatantly in the negative without any air balancing. 30 exhaust fans against one supply fan. Where would you start? Is air balancing still the first step?
Well, the first thing I would do is check underneath the doors when the fresh air is supplied to the hallways. It's designed in most cases so that there's a space underneath the door for that air to enter into the apartments or the units so that they don't become negative. And if there's been any retrofits, make sure that that doesn't happen. Often people will buy these door snakes and throw them at the base of the door. If they might feel a draft or they don't like the noise coming in from out in the hallway. And then making sure that the exhaust fans and the ducts are functioning correctly. Then another obvious thing is if the air handler has been changed recently, make sure that, and if it's not the original air handler, make sure that the air handler is the correct size and that the CFM, the cubic CFM of the exhaust air and the cubic CFM, the cubic feet per minute, the supply air match. And you can do that with simple math by looking at the nameplate data on exhaust fan and crossing that over. You can Google everything today, and then you can go look at the supply air to the building and find out what its CFM is, make sure that they're matched and you don't have something imbalanced, which may be the case. Hopefully does that answer the question? Sasha, did I miss anything?
Nope.
And that person, that if they've texted that in, let us know if that answered the question or not. And you can contact us offline also.
All right, Kent, let us know if that helped. Okay, we have, how often should we replace a MERV 13 filter versus standard filters?
Yeah, I just responded to that one in a written format, but there's no answer that we can give. It really, environmental conditions of where your building is located, the amount of pollution that it's collecting and so forth have to play into that. But do know that it's considerably more dense than a standard pleated filter or non-pleated filter. Any MERV filter is. So the more dense it is, the thicker it is, the more it collects, the more it gets trapped there. So the more reduced the airflow is going to be as it collects these things. So replacing it is certainly going to happen more frequently.
And you might have some larger air handlers have a differential pressure across the filter. So look at that, but they'll have to be replaced more. And also, if you're going to increase the MERV rating of your filters, make sure that the manufacturers of the air handler that is okay, because many times they'll give you the max MERV rating of the filters.
Okay, how often do the lamps need to be replaced?
Annually. Some manufacturers will tell you every 2 years or whatever have you. I can tell you that in working with the brand Sterile Air, which is a local brand, they have third-party testing from Department of Homeland Security. Actually, many years ago, tested their lamps as the highest output levels of any other competitors, and they recommend annually. The lamps do degrade over time, and just because they shine doesn't mean they're actually doing their job. Keep in mind, you're not installing these UVC lights to illuminate an area, you're installing them to kill things. So just because they're illuminating doesn't mean they're working. Manufacturers should be, do recommend every year, once a year. Like I said, some might every 2 years. I would stick with every year.
Thank you.
The lamps are fairly inexpensive once the product is installed. The lamps are not going to be a cost barrier. Really, the barrier is going to be the initial installation of the product with the kit.
Okay, Sasha, I'm going to share these two questions that you answered. What new technology might you recommend for elevator ventilation during these COVID times? And Sasha just says that UVC lighting may be a viable solution depending on the ventilation configuration. Another question, are you seeing buildings requesting retrofit controls to aid in the mitigation of the spread of COVID? Sasha responded, we are seeing a massive uptick in UVC lighting retrofits and conversations on building air balancing. Ted, do you have anything to add to that?
I haven't seen any requests in controls other than making sure that the existing control system is working correctly. And if you do not have a building control system and you have a large building, particularly with a central plant and multiple air handlers, if you don't have one, it would be advantageous for your own operational staff to have one. Certainly, it lets you know wherever you have points, you can set up alarms so you know when there's a problem before the building, before things become a problem and your residents have issues.
How often should duct cleaning be conducted?
I hate to give the answers of as needed, but there are really so many, there's so many unique circumstances to all of this. I don't want to steer anybody wrong by giving you a defined period of time. Obviously, you've got everything from your dryer exhaust ducting, which collects lint and is a fire hazard and certainly should be kept up with annually, to exhaust systems for bathrooms and kitchens. Cleaning the entire vertical shaft of an exhaust fan duct is in our opinion, rather unnecessary. The shaft is usually many square feet in diameter. However, the goosenecks that are the individual exhaust registers that are in the apartments, the register and the gooseneck that feeds the main shaft, that is the point of constriction in all of these. So by removing that register and cleaning that area up through the penetration into the main duct, that is the most important. Once again, I can't tell you what your building is requiring.
And that's very important up through into the penetration to the main shaft.
Yeah.
So often the runouts of those, depending on how it's designed, how far that is, that you can't just reach in and just clean around it. You have to go down that piece to the main shaft.
We have an air handler that is located outside an apartment at the balcony utility closet. The outdoor temp contributes to our condensation problem. Is it necessary to keep this type of door?
Type of door?
Say it again.
Okay. We have an air handler that is located outside an apartment at the balcony. I'm guessing it's inside of a utility closet.
Okay.
The outdoor temperature contributes to the condensation problem. Is it necessary to keep this type of door? I'm guessing the door to the utility closet.
It's a little hard to tell from the question what you're talking about, what door.
Okay, it's an anonymous attendant.
Air handler is in the closet and it has louvers in it because it needs ventilation. I would say yes. It's very important. If there are louvers in it, it sounds like you might have an open door. But if you've got condensation running out of it onto the balcony, you have another problem that needs to be looked into. It could be a condensate drain problem. I would really look into why the condensation is a problem. I think that's what the question is.
My assumption is if an air handler is in the closet outside of a balcony, then that return for that air handler, meaning the air that comes into the air handler to then be cooled or heated and discharged, the return air should be ducted into that apartment. it shouldn't be pulling from the outside space.
Well, that might be
But it very well could be. I've seen plenty of
yeah, if there was gas heating to the air
Yeah.
handler for the winter,
Yeah.
that's why it's there for combustion air. Yeah.
Yes, they said that
A
they
little
do.
hard to tell from the question. I'd be happy to entertain that question offline from that person, as well as Kent's question about the negative buildings. Maybe Sasha and I could get on a conference call or something.
And they did respond. It is a louver door.
Okay. Yeah. Yeah. I look into why it's a louver door. I'm assuming there's the air handler. Maybe it's a heating and cooling air handler. I'm sure it's there for a reason, but we'd have to take a look at it.
Then I believe this is the last question. Actually, it's a side note. Can you conduct a seminar on controls and retrofit pneumatic to DDC?
Oh, yes, we could. It depends on the demand. If there's a high enough demand. NAPE has some controls classes, and I would be happy to address controls questions. Sasha may want to do that also. We could do maybe a conference call with a few people to address some specific questions if that's what they have. But yes, we can do controls seminar. Sure.
Well, it looks like you will be doing a controls seminar because there's some people that are interested in it.
Yeah.
As I'm seeing.
I'd like to get some more questions on what type of controls and such. But this whole retrofitting of pneumatic to DDC, that's a big topic.
So here we have another question. How are PTACs viewed with fresh air requirements in apartments and hotels regarding the COVID?
PTAC units are wall-mounted units. They're essentially they're heat pumps, essentially, right? They're wall-mounted AC units. They exhaust the hot air to the exterior building through louvers, and the interior air is recirculated through a very small filter. It's basically a reusable mesh filter usually, and it produces hot or cold air. It's very similar to a standalone console-looking fan coil unit. It's a convector-style unit in appearance. There is no outside air that those things are bringing in, unless that was in the original design where they have a damper that brings in outside fresh air. I haven't seen that yet in an example in any of the buildings that we've looked at. Maybe Ted has, though, in his passings.
Well, typically the PTACs are for one particular apartment. Mm-hmm. So,
or room, really.
Yeah, or one room. And it depends. If you have a family living in the apartment and they're sharing rooms, it may not be an issue. But if you have multiple people, maybe multiple families living in there, because they're bringing fresh air in, and the cross-contamination of the family typically isn't an issue because everybody's living together in a closed-in space. But if it used externally for multiple apartments or a hallway, that's something different.
All right. It looks like we have answered everyone's questions in the Q&A and in the chat section.
And I'm happy if people have my contact information for additional questions offline.
Yep.
Sasha, you too?
Yep. Always.
Well, great. Thank you all for attending our lovely seminar. And thank you, Sasha and Ted, for sharing your expertise with everybody. And I will pass it back over to Sarah.
Great. Yes, to echo Elizabeth's words, thank you all for joining us today. Please stay tuned. We'll be doing a survey soliciting your feedback about this webinar and also seeking your suggestions for future webinars. So let us know what you'd like to learn about, and we're here to serve. So keep an eye out for that, and we'll be seeing you soon. Thanks so much.
Thank you.
Thank you all.
Thank you.
Thanks for setting all this up, Sarah.
Oh, my pleasure. Thank you.
Thank you very much.